All right, guys, how is it now?
It's fine. Now
It's
we
fine.
can see.
All right, no, thank you. I think there was a problem there with connection because I could see everything. I don't know what was happening. Okay, so I was talking about finance. Finance is part of paper one, and usually finance comes around it's question number 7 or question number 8. So finance is divided into number one, simple interest and decay, which was done in somewhere around grade 10, then grade 11. Even at grade 10, you introduced compound interest and decay, but at grade 11, there was now change in compounding periods. Okay, then also timelines. That was in grade 11. Then grade 12 comes with annuities, and annuities are divided into future value annuity, number B, present value annuity. Then number C, we have deferred payments. Then number D, we have after deferred payments, we have outstanding, balance. Then number E, we have what is called the final payment. We have what is called the final payment. Okay, so the way I'm going to approach our finance is in this way. There's nothing much I can talk about. I'll tell you the formula and I will tell you when to use the formula. Okay, then that is for simple interest. For compound interest, I'll say some other stuff there. Then what I'm going to explain more is on annuities. Okay, so this is the way we are going to have our lesson. Then afterwards, I hope we are going to be able to finish the questions that I've sent to you. Okay, so finance, simple interest, it's simple as it is. That is the first thing in finance. Number one, simple interest. Right, simple interest now at grade 12, it doesn't work that much, but it's good to know it. And you are given the formula in the formula sheet, which says 1 plus I n. A is equals to 1 plus P in brackets 1 plus I n. Okay, so this one I'm going to write it now and I won't repeat it again. Where A is, what is A? Who wants to tell me? Okay, accumulated amount. Then P, what is P?
Principal.
Is the principal amount. Principal amount. Okay, which is actually the initial amount or the amount invested. Where I, what is I?
Interest.
That is the interest rate. Where N, what is N?
It's the number of the year.
Number of periods or number of years. Okay, so that is simple interest. So this one I won't repeat it again. Okay, now we know what is A, what is P, what is I, and what is N. But this one is different, sort of different to what we call simple or straight line depreciation. Straight line depreciation is simple decay because decay is loss in value. Okay, so straight line method of depreciation, it is actually the loss in value of an asset over what? Over time, or the reduction in value of an asset towards, over time. For example, if you buy a car, when you're using it, the value does not stay the same because you are using it. There is wear and tear. So what happens to the car? It loses value as you are using it. So that is depreciation. Again, it's A is equals to P in bracket 1 minus. Now, when its depreciation is minus N. Okay? So when it's depreciation, A now changes to what we call the book value or depreciated amount, depreciated value. Then P is the cost price, the amount at which we bought the item. So in depreciation, you'll find that A is smaller than P because this is decay. This is reducing in what? In value. Then I is depreciation rate. Then N, number of periods. In depreciation, they are usually what? They are usually years. They are usually years. Okay, so that is simple interest, and simple interest, it has its friend, which is simple decay, but we call it straight line method of depreciation. Okay, now we move on, we go to the second one, number B, number 2, which is compound interest. Now, compound interest is just A is equals to P in bracket 1 plus I to the power of what? N. Okay? But what is interesting under compound interest is change in compounding periods. Okay? For example, we are given an interest rate per year, but the interest rate is compounded monthly, or it's compounded quarterly, or it's compounded half yearly or semi-annually. Okay, so it means in a year we are no longer having, or we are no longer compounding once, but when we say monthly, what does it mean? It means now in a year we are compounding what? 12 times. Quarterly, how many quarters are there in a year? There are 4 quarters. Then, okay, let me try to separate them so that I can do something. Okay, monthly, we said there are 12 because there are 12 months. Okay, so we no longer use the yearly interest rate. We need to find the monthly interest rate, which is going to be I divided by 12. Okay, the interest rate we are going to, because the interest rate that will be, the interest rate that will be given, it's a yearly interest rate. So in order to find the monthly interest rate, we have to divide the yearly interest rate divided by what? 12. Okay, so the number of periods, what do we do? N multiply by what? By 12. So you're going to divide by 12, multiply by 12. Divide by 12, multiply by 12. So quarterly, there are how many quarters? There are 4 quarters. So I is going to be I over 4. Then N is going to be N multiplied by what? 4. For example, if we have 4 years, we are going to have 16 periods because it's going to be 4 times 4. Okay, half yearly, there are how many half years? 2. So the interest rate is going to be I divided by 2. Then number of periods is going to be N multiplied by 2. That is how you do it. That is change in compounding what? Periods. So each and every time they say quarterly, divide by 4, multiply by 4. When they say monthly, divide by 12, multiply by 12. When they say half yearly, divide by 2, multiply by 2. So that is how we deal with compound interest. Okay? Then the brother to compound interest is what we call the reducing balance method of depreciation. Some they say diminishing balance. Diminish, to diminish is to reduce. So this one is A is equals to P in bracket 1 minus I to the power of N. So you see, they're almost the same, but because it's depreciation, the difference is that there's plus because it's growth. This one is going to be minus because it's decay, it's a reduction. So there's minus there. So that is just the difference between the two. But these formulas, usually you are given. Okay? Any questions so far, guys? Or a confirmation, are we together?
Yes, sir.
All right. Then we go to annuities. Oh, on annuities, I'd left sinking fund. Okay? Annuities. Annuities. What is an annuity? Okay? On annuity, we need to distinguish an annuity from a loan that is going to be paid once off. For example, if I borrow today and in a year I have to take back all the loan with the interest, that is not an annuity. Okay? But an annuity now, it is an investment or a loan where equal payments are made at regular.
Is it me or what? I'm not hearing you. Is it me?
I think it's you. Guys, can you hear me?
Yes, sir.
So I think, Jackie, it is you. Okay? So it is an investment or a loan where equal payments. Jackie, can you hear me now?
Yes, sir. I can hear you, but it was not me.
Oh, I thought it was you. Okay,
No.
the voice.
No, sorry,
It is
me, but I can hear.
all right, all right. Sorry, Jake. I thought it was Jake. It is an investment or a loan where equal payments are made at regular intervals. Okay, I want to give you a real life example of an annuity. Okay, we know that people buy cars. When people buy cars, we celebrate you've bought a car. But what do? In order to buy those cars, the cars are paid fully. Let's say you're buying a car from Toyota, it's paid fully. How? We say the car was financed. How was it financed? Because you have taken a loan. Where do you take a loan? From the bank. Okay? Then what happens? Obviously, if you take a loan, the bank is going to charge what? Interest. Right? So, what do? Each and every month, you are going to pay equal payments to the bank towards finishing that loan plus the interest accumulated. That is an annuity because each and every month you are going to pay equal payments. If you are paying 3,000 every month, you'll be paying what? 3,000 until you amortize that loan. Amortizing a loan is finishing paying the loan plus the accumulated what? Interests. That is amortizing a loan. Okay? So we have two types. Number one, we have what is called future value annuity. Ne? So here, equal payments are made in an investment account such that the money you're going to use it in the what? In the future. So you open an account now so that you'll be putting money in the account at regular intervals such that the money is going to accumulate and you're going to withdraw that money for use in the what? in the future. So future value annuity, I love FV, but if in the formula sheet it's written F, okay, is X into 1 plus I to the power of N minus 1 over I. That is the future value annuity formula. Where X, what does X stand for? Where X stands for the equal payments. Okay, so if you have decided that I'm going to be saving 5,000 each and every month, it means every month you're going to be putting what? 5,000 in the account. That is X. Okay, then the next one is present value annuity. Present, that is number 2, present value annuity. This is a loan now. Paid by equal payments at regular intervals. This is a loan paid by equal payments at regular intervals. Okay? So the example that I gave there of buying a car, that is a what? A loan at regular intervals. Okay? That is a present value annuity. Right? So the formula for present value annuity says PV is equals to X. So this is the loan amount. It's equals to X, then in bracket 1 minus, then 1 plus I to the power of negative N over I. That is the formula for the present value annuity. However, there are instances, guys, are we together? There are instances where a present value annuity can be an investment. Ne? For example, lottery. For example, inheritance. For example, retirement. Okay, I want to explain how these ones becomes present value annuity. Guys, let's interact. Okay, lottery. Oh, I wish I could win lotto. Lottery, you get a lump sum. How much is the Powerball now? I don't know how much it is, but let's say you get 5 million. If you get 5 million, can you use all of it? No. What can you do? You can put it with the bank and instruct the bank to pay you a certain amount of money every month. For example, you can instruct them that each and every month, I want 20,000. So the money that you have invested with the bank is going to earn interest, but they will pay you 20,000 until your money is finished with the bank. So this one becomes present value annuity. The bank has taken a loan from you because you have a lump sum. That is the same as inheritance. If a rich uncle dies, in their will, they've written that you are supposed to inherit maybe 10 million. You cannot use all of it. You can take 8 million. You can chow 2 million and take 8 million and invest it in a bank and instruct the bank that each and every month you have to give me 30,000 until the 8 million plus the interest end until they get finished. So this one becomes a what? A present value annuity, in the sense that the bank is the one that has borrowed money from you. So they are paying the loan to you. Also in retirement, when people retire, they get lump sums of money. So they can leave the lump sums by the bank, then they instruct the bank to give them a certain amount of money each and every month. Okay, so these are the two annuities that we have: the present value annuity and also the future value annuity. Okay, then the other stuff I'm just going to explain. If there's a formula, I'm going to write it down. Then we have a sinking fund. Sinking fund. A sinking fund, it is an account opened to replace old assets in the future. Or I skipped there. It is an account opened to raise money to replace old assets. So there, if you're writing, just write there, to raise money to replace old assets in the future. What happens with old assets? Old assets, they depreciate. But what do we do with old assets? Do we throw them away? No, we do not throw them away. What do? We go and we trade them in. Ne? Or we can sell them. Then the money that we sell them, we can actually add it to the money that we have and go and buy a new asset. What happens to new assets? New assets, their prices, they always what? They always increase. Why? Because of a factor that is called inflation. There is inflation. Okay? Inflation, it is the general increase of prices in an economy, and it's given as what? As an inflation rate, which is a percentage. Okay? So for old assets, the future or the value in future, remember that is going to depreciate. It's going to be A, I'm going to call it A1, is equals to P1 minus I to the power of N. Usually here, the depreciation that we use is reducing balance method. The new assets, the price in the future is going to be A, I'm going to call it A2, P1 plus I to the power of N. Inflation, it uses what? It uses compound interest formula. So this is the future price, okay? So what are we going to do? This is the amount, or this is the price of a new asset, right? But already we have something. We have the money that we obtained from selling an old assets. So how much money do we need in the sinking fund in the future? So sinking fund amount is equals to A2 minus A1. Okay, so that we know how much money do we need to raise. Then you need to know that this amount is a future value, which is a future value amount that we need. So we use what? Future value amount, future value formula under sinking fund. So sinking fund, it has three things. It actually has four things: depreciation of old assets, inflation of new assets, then calculating the sinking fund amount. To calculate how much money we need to deposit in the sinking fund account, we use FV is equals to X into 1 plus I to the power of N minus 1. This is the future value what? Formula. So usually we want to calculate this because this one is this amount. Then the other stuff we are given. Okay? Right? Then we have deferred payments. We have the last payment. And we also have balance outstanding. Okay? Balance outstanding is the formula that I want to give you. Then the other stuff, you're going to look at them from the stuff that I've given you there. Okay? Outstanding balance is equals to, this is outstanding balance, is equals to X into, I want a simple formula that is easier to use. So I'm going to use the simple formula Oh, sorry, before that. Sorry about that. Let me write outstanding balance. What is outstanding balance? Outstanding balance, it is the loan amount still owing after a certain of payments. On a loan, then you've paid after 4 years. You've paid and you want to see how much money am I still owing. You calculate the outstanding what? Balance. So outstanding balance, which is OB is equals to X into 1 minus 1 plus I to the power of negative N, then in brackets minus K, right, over I. N, we know it, the number of periods needed to finish paying the loan, where K is going to be number of payments already made. Okay, that is the outstanding balance. That is the outstanding balance. Okay, so guys, we are 30 minutes into our lesson. I want to end here. When we meet deferred payments, I'm going to explain deferred payments. So now, guys, let's go into our worksheet and look at the problems that we are having. Okay, right. Who can read for us the first one? The first one that is written finance on the question paper that is written finance. Guys, am I talking alone? Guys, am I talking alone?
No, sir. You are not talking alone.
All right. All right. If you check, I sent two. I didn't name them, but they are distinct because the other one on top is written financial mathematics. There's question number 7. Okay. So question number 7, it's saying 7.1. It's unfortunate that they are just question 7. Another one we get question 8. Okay. Or question 6. Right. 7.1. An amount, let's interact. An amount of 10,000 was invested for 4 years, earning an interest. Okay, so now we see that this is a once-off investment. So an amount of 10,000 was invested for 4 years. Okay, earning interest of R% compounded quarterly. So we divide there by quarter. Then it means on N, we are going to multiply our N by what? 4. Okay. The total amount in the account, now the accumulated amount in the account is 13,080. Calculate R. Okay. Guys, what are the keywords here that tell us the formula to use? Oh my God, am I alone today?
The compound.
Compound.
Compound
Yes.
interest.
Compound interest. And also, this one, it's a once-off investment because remember that this 10,000 is not deposited each and every what? Month or after a quarter or what. So it's once off. So it means this one is a once off. So we are going to use A is equals to P in bracket 1 plus I to the power of what? N. And our A is 13,080, which is equals to 10,000 into 1 plus, what is R? What is I? I is R. And remember that this is compounded what? Quarterly. So we divide by quarter because there are 4 quarters. Then to the power of 4 multiplied by 4. Okay? So how do we calculate now? Remember there we are having multiplication. So the opposite of multiplication is division. So what I'm going to do, I'm going to first start by dividing by 10,000. Divide here by 10,000. Divide here by 10,000. So that this one and this one, they cancel. Then you punch that in your calculator and see what it gives you. Please try to use fractions as much as possible. Do not round off. You can only round off the final answer. So 13,080 divided by 10,000, what do we get? What do we get? Today I'm alone. You guys, you are too quiet today. We get 327 over 250, which is equals to 1 plus r over 4 to the power of 16. Okay, how do I remove the power of 16? How do I remove the power of 16?
Log.
Not logarithms. Remember, it's a power. The opposite of a power is a root. So this is going to be the 16th root. The 16th root, such that now the 16th root of 327 over 250 is equals to 1 plus r over 4. Okay, so it means r over 4 is going to be the 16th root of 327 over 250 minus 1. We have taken 1 across, it becomes minus. Then there you can punch in your calculator and see what it gives you. Use your calculators, guys. Shift the 16th root. Then in the bracket there, 327 over 250. Then you get out there minus 1. Now there you get r over 4. I'm going to use this part. If you can see, r over 4 is equals to 0.0169222, going on like that. Then multiply that by 4, because to remove this 4, you have to cross multiply. Multiply that by 4. You are going to get 0, r is equals to 0.0676911, blah, 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 blah. Then multiply that one by 100 to convert it to percentage. Then you're going to get 6.77%. Okay, so what did we do here? This part, you understand it. Then moving there, to remove 10,000, we divide both sides by 10,000. Then after that, you simplify this one so that it becomes a fraction. Then here, we have to the power of 16. We divide it by 4. We multiply by 4 there because of quarterly. Okay, then to remove the 16, we introduce the 16th root. Then there we are moving on. We have taken 1 across side that we are now left with r over 4 is equals to the 16th root of 327 over 250 minus 1. We punch this one in the calculator. It gave us that one. You have to write all of it. Then we multiply by 4. Then we multiply by 100. Then we got the answer being that one. Guys, any questions? I hope not. Okay. Now let's go to 7.2. Let's go to 7.2. 7.2 is saying, who wants to read for us? So that at least we can interact. Guys, somebody to read for us?
Can I read?
Yes, you can read.
Sorry, sir.
Yes, you can read.
It's what? It's 7.2.
Yes.
I don't know if I can see it. A business, is this one? A business woman deposited rand 9,000 into an account at the end of January 2014. And then she continued to make monthly deposits of rent 9,000 at the end of each month. Up to the end of December 2018. The account earns interest at the rate of 7.5%
per annum, per year. Compounded monthly. Thank you.
Yeah, per year.
Thank you. I just wanted to confirm whether we have the questions. Yes.
Oh.
Thank you. Calculate how much money was in the account immediately after 60 deposits had been made. Okay? So, let's check here. A businesswoman deposited 9,000 in an account at the end of January 2014. And she continued depositing 9,000 at the end of each month. So you see, there's a regular payment. How much is the regular payment? How much is the regular payment? It is what? How much is the equal
9,
payment?
9,000.
It was 9,000. Each and every month, there is 9,000 that is being deposited in a what? In an account. So, money, is this person paying a loan? No, they are not paying a loan. They're actually investing 9,000 each and every month. So this one becomes a what? A future value annuity. Why? Because there are equal payments and money is needed in the future. So this is 1 plus I to the power of n minus 1 over I. Okay? Like that. Let me use another marker, a red one. Okay? So now they are asking 7.2.1. They are asking, calculate how much money was in the account immediately after the 60th deposit. Okay? So this is going to be, how much are the equal payments? This person is making 9,000 equal payment. Okay? 1 plus, what is the interest rate? Check, guys. What is the interest rate?
7.5.
7.5. Now 7.5%, it means 7.5 over 100. If you have a calculator, do 7.5 divided by 100, what do you get?
0.075.
We get 0.075. Okay. Right. Then this is compounded how many times in a year? Check. They said compounded what? Monthly, quarterly, or yearly?
Compounded quarterly.
They said compounded quarterly. Did they say compounded quarterly?
No, I'm thinking I'm using the first one. Compounded monthly.
So it means this one you divide it by what? By 12.
By 12.
Yes. So how many payments were made? Is there on the question? That is the number of periods. That is n. How many payments were made? 7.2.1. Read that one.
60 deposits.
Right. So it means 60 deposits. It's how many years? 60 divided by 12. It's how many years?
5 years.
It's 5 years. It's how many years? It's 5 years. Okay. Minus 1 over 0.075 over 12. Okay. Then you take your calculator. There's an item like this on the calculator. I think you know that. You first press this one, then on the numerator, you put that one, you press the down arrow, then you go to the denominator, you punch that one. So let's do that and tell me the answer. We can only proceed after somebody gives me the answer. What did you get?
I'm getting 652743.9479.
Now we round off because that is the final answer. We round off to 2 decimal places. Okay. So this is going to be 65273.95. Did we manage to get that one, all of us? That is the future value. So guys, this is so simple. This one is actually carrying how many marks? It's carrying 3 marks. Where do the 3 marks come from? 3 marks comes from that one. Then the proper substitution in the correct formula. Then the final answer. So this is so simple. This is so simple. Okay. So let's move on to go to the next. The next one, 7.2.2. Look at the marks that are there. It's 6 marks because it's quite sensitive. Okay. So I am going to try and be fast about this one. So if you don't quite catch it up, you're gonna get it in the video and play it again and again. I'll try to be thorough in my explanation. Okay. 7.2.2. It now says the businessman left the amount accumulated in 7.2.1. So it means she left 652,743.95 in the account. Okay? For a further n months in the account, the interest rate remained unchanged and no further payments were made. The total interest earned over the entire investment period was 190,214.14. Determine the value of n. Okay? So over the entire investment period, it means over the 5 years and also over n years. Okay? So interest, right, it was earned on 60 periods plus n periods. Then the interest that was earned was 190,214.14. Okay? So it's possible for us to calculate the interest that was earned in what? In the first 60 months, in the first 5 years. Okay? So I'm going to calculate interest in the first 5 years. So remember that the interest usually is equal to the accumulated amount minus the principal amount. So the accumulated amount, remember that the accumulated amount was 652,743.95 minus the invested amount. Let me just write it this side because the amounts are quite big. 652,743 minus 0.95 minus what was the amount that was invested? This person invested 9,000, right? Times how many times? Times 60. Because 9,000 was deposited in the account for 60 months. Okay? So what are we going to get? We are going to get 9,000 multiplied by 60. We are going to get that the interest that was earned in the first 5 years was 1,102,743.95. That was the interest that was earned in the first 5 years. The accumulated amount minus the amount that was invested, which is 9,000 times 60, because 9,000 was deposited how many times? 60 times. Okay. Then we go on. What was the interest in n periods or in n period? It was the interest is going to be the total interest, which is 190,214.14 minus the interest rate for the 5 years, which is 652,743.95. Okay, then we subtract that 190,214 0.14 minus 652,743.95. Okay. What did I do now? Sorry. Minus 112,743.95. Sorry about this one. Okay. 112,743.95. Okay. Now we get that in the n period, after this one was left for n periods, the interest that was earned is 77,470.19. That was the interest that was earned in n periods. Okay. So now that we know the interest, we know that this was left out to earn this interest. So now, in order to get A, the accumulated amount, okay, I'm going to rub here. In order to get A, the accumulated amount, it is going to be the principal amount plus the interest. So what was the principal amount? It was 652,743.95. What was the interest that was earned? It was 77,470.19. Okay, we add those two plus 652,743.95. Then we get that in the account at the end of n periods, we had 730,214.14. Okay, this is the amount that we have in the account. So now we have our A and we have our P. Okay, we have our interest. What we don't know is what is N. Okay, so we know that A is equals to P in bracket 1 plus I to the power of N, because after they've left this amount and they are no longer depositing 9,000, it ceases to be an annuity. It becomes a what? Just a compound interest, a once-off investment. So A is 730,214.14, which is equals to P 652,743.95 into 1 plus I. They say the interest rate didn't change, over 12 to the power of n. We can say 12n, but if we say 12n, it means when we divide, we are finding the number of years. Okay. Now, from there, in order to get n there, we are going to go and use logarithms. So what do we do? Now, from there, it's simple to calculate. We divide both sides by 652. So this is going to be 730,214,14 divided by 652,743.95 is equals to, in the bracket there, we add 1 plus 0,075 over 12. Then we get 161 over 160 n. Okay, so I heard the other one says logarithms. We use logarithms to find the unknown if the unknown is in the what? In the exponent, like that. The base of the exponent becomes the base of the what? Logarithm. Okay, so this is going to be n is equals to log 161 over 160, then in brackets 730,214,14 over 652,743,95, like that. Then you get your answer. So guys, let's take the calculator and use the logarithm. On the base, on G there, that is where you put 161 over 160, then into the brackets 730,214,14 over 652,743,95. Then you see that we get 18 months. We get 18 months. So it means this person left this amount of money for 18 months, for further 18 months after the expiration of the 60 months. Okay, so this one, it can be proving to be a bit challenging because it's 6 marks, of course, but after when you're on your own, I want you to go through the video and see the steps that you have taken. They make so much sense. Okay? I hope I didn't confuse some people. If you're confused, you can be redeemed. Okay? Let's look at the second question, which is question number 7. Any questions on that? All right. Let's move on to go to the second question, number 7. All right. Question number 7. The next one. 7 again. This is the second one. It says, a business buys a machine that costs 120. The value of the machine depreciates at 9% per annum according to the diminishing balance method or the reducing balance method. Determine the scrap value. The scrap value is the same as the book value of the machine after 5 years. That is 7.1.1. Okay, so now they said the diminishing balance method, meaning to say we are going to use P1 minus I to the power of what? N. How much was the cost price? The cost price was 120,000. And the depreciation rate was 9%, which is 9 divided by 100, which is 0.09. For how many years? For 5 years. Calculate and give me the answer, guys. I'm waiting. Calculate and give me the answer. Are we calculating? Are we calculating? Precious?
I get 74,883.
74,800 and what?
83,86.
86. Okay. Are we getting the same, Leslie? Is it Leslie who's speaking?
Yes, sir.
Okay. Others, are we getting the same?
Yes, sir.
All right. Yeah, that's correct. 86. So that is the scrap value. So it means the machine, after 5 years, it has a value of 74,883.86. Okay. I sense that this one is a sinking fund. Let's move on. Okay. Then we move on to 7.1.2. After 5 years, the machine needs to be replaced. During this time, inflation remained constant at 7% per annum. Determine the cost of a new machine at the end of 5 years. Okay? So here, we are going to talk about inflation. And I told you that inflation, it uses what? The compound interest formula. So we are assuming that the machine was costing 120,000 5 years ago. So how much does it cost now? Okay, so it's going to be 120,000 into 1 plus 0.07 to the power of 5. How much do we get? That is inflation. How much do we get? How much do you get? 168, 306.21. Okay. So usually, if we're going to calculate the amount that we need in the sinking fund, we're going to say sinking fund amount, the amount that we need in the future. We're going to say 168,306.21 minus 74,883.86. Why? Because we are going to sell this machine, then add the money into the money that is going to be the account so that we can get this amount. Take the two amounts, go to the shop and buy a new machine. So it means how much are we going to get? 74,883 86, we're going to get something like 93,422. Okay, let's continue with the question. If you, the question is saying, after 5 years, the business estimates now that it will need 90,000. So you see 90,000 is close to 93,000. So they've estimated that they've rounded off that they will need 90,000 by the end of 5 years. A sinking fund for 90,000 into which equal payments must be paid is set up. Interest of this fund is 8.5% per annum, compounded monthly. The first payment will be made immediately, and the last payment will be made at the end of 5 years period. Calculate the value of the monthly payments into which the sinking fund, or payments into the sinking fund. They made a typing error there. Okay, into the sinking fund. Okay, so what are we saying? We are saying the future value that is needed is 90,000. Right? Okay. Interest rate is given as 8.5, then monthly. So calculate X. So we know that future value is equals to X into 1 plus I to the power of what? To the power of N minus 1 over I. Okay? Then here we want to calculate X, the equal payments that this person is going to make. So what we need to do, or to make X subject of formula. So this is simple. Take I is going to multiply there. So I'm going to say X is equals to FV multiplied by I over. Then if I've multiplied there, to leave X alone there, I have to divide by this part of the interest. So that is going to be 1 plus I to the power of N minus 1. Okay, so if I can take it there, I can say in order to remove I am going to do cross what? Multiplication. So I'm going to get FV multiplied by I is equals to X into 1 plus I to the power of N minus 1. So I'm going to divide by 1 plus I to the power of N minus 1, both sides. 1 plus I to the power of N minus 1. Such that this one and this one, they cancel. So you see, I've made X subject to formula. Okay, so this one, I am going to write it as X is equals to FV dot I over 1 plus I to the power of N minus 1. Okay, so the future value that is needed there is 90,000. Okay, the interest rate is 0.085. Please don't guess, because people, they have a tendency of saying this is going to be 0.85. 0.85 means 85%. Okay, and this is compounded 12 monthly, right? Over 1 plus 0.085 over 12 to the power of, now they said for 5 years. So it's going to be 5 multiplied by 12. But do not forget one thing. They said there is an immediate payment. Each and every time they say there is an immediate payment, add 1 payment. Okay, so 5 times 12 is 60. So this is going to be 60 plus 1, which is 61. Then minus 1. So this person is going to make how many payments altogether? 61 payments. Okay, so now you take your calculator and punch in your calculator like that. Then you are going to get 90,000 multiplied by 0.085 over 12, right? Then in brackets 1 plus 0.085 over 12. You close the bracket to the power of 61, then minus 1. Then you are going to see that this person needs to deposit 1,184.68 rand each and every month. Okay, we are going to deposit that amount. So this is calculating X. The future value that we need, the interest rate, and N. You need to be careful there. There's an immediate payment. So we are told the number of years, but we know that they're going to be payments each and every month. So how many payments are there going to be? They're going to be 5 times 12 because a year is 12 months. Then you have to add 1 because there's an immediate payment. Okay? Thank you. Let's go to 7.2, which is going to be the last one for today. Then I think the next time we meet, we still need to look at finance. Okay? Right? 7.2 says Lorraine receives an amount of 900,000 upon her retirement. The moment they say retirement, I know that this is a present value annuity. Why? Because she's going to invest it. Okay? She invests this amount immediately at an interest rate of 10.5% per annum, compounded monthly. She needs an amount of 18,000 per month to maintain her current lifestyle. She plans to withdraw the first amount at the end of the first month. For how many months will she be able to live from her investment? Okay, so PV is equals to X, right, into 1 minus 1 plus I to the power of negative N over I. The present value, the loan that she gave to the bank, is 900,000. Then she wants to withdraw 18,000 into 1 minus 1 plus, then the interest rate is going to be 0.105 over 12 to the power of negative N over 0.105 over 12. Okay? So, guys, the way we work here, to remove this one, we cross multiply. So, crossing multiplying there, this is going to give us the working. I'm going to do it in blue. This is going to give us 0.105 over 12 multiplied by 900,000. Then over, then we divide both sides by 18,000 later. Divided by 18,000. Then you are going to be left with 1 minus, then in brackets there, you can add 1 plus 0.105 over 12. Then you get 807 over 800 to the power of negative N, like that. Okay? Right? So this one doesn't need a bracket anymore. So now let's work out here and see what we get. That is going to be 0.105 over 12 times 900,000 over 18,000. Right, then you're going to get 7 over 16 is equals to 1 minus 807 over 800 of negative N. Let's take this one, that side, because it has a negative, so that it can be positive. We have 807 over 800 over negative N is equals to 1 minus 7 over 16. Okay? 1 minus 7 over 16 is going to give us 9 over 16. So we have, okay, we have 807 over 800 to the power of negative N is equals to 9 over 16. Then this is where we use logarithms. Negative N is equals to log. The base is 807 over 800, then in brackets 9 over 16. And see how much we get. Okay, let me try to go back this side and see how much we get. So it's negative, let me use a different color. This one is fading. Negative N is equals to log 807 over 800, then 9 over 16. Use your calculator. 807 over 800, then there we get the that negative n is equals to negative 66,04, blah, blah, blah. So it means n is approximately going to be 67 payments. What it means is that there is going to be 66 payments of 18,000 and one last payment that is going to be less than 18,000. So this person is going to get 67 payments of 18,000 each and every month. All right, guys, finance, I know finance to many it's boring. I know it's confusing because of the English, of the things that we need to do. But guys, you have a positive mind. Finance, you can actually pass it. And it has a lot of part marks that you can actually get. So try to do what we've done today. Then the next time we meet, we are going to finish the other page because it actually is some things that are interesting. Then I'm going to add some more questions there. Then we'll be done with finance. Otherwise, guys, I don't see any questions. Please comment with any word that you got from the lesson. Then we are going to meet again next week on Sunday. You have a wonderful week until we meet again.